Okay, so let's try this out. Can you guys hear me? I know I had some difficulty yesterday and I'm trying something different today. So if you can let me know if you can hear me, that'd be great. All right, let me know if you guys can hear me. I had some technical difficulties yesterday for office hours, so I had to cancel those, unfortunately. I want to make sure things are working right and you guys are able to hear me. All right, so I get some confirmation you guys are able to hear me. Thank you. And now my question to you guys, so I could kind of help out, figure out what's going on here, is how did you find this correct link? I know there's been issues about what link to use. My question is, how did you know that this was the right place to go for streaming? This is for Unit 1, by the way, just to make sure. And because I want to make sure that everyone knows where to go, because there's been issues with, at least on my end, how this works. Okay. All right. So we got people joining in. So someone got a notification. I see. So you set up a notification and then it says, "Hey, this is where it is." All right. Thank you. Looks like people have set up the notifications. All right. Appreciate that. I see some. I was gonna say some familiar faces, but mostly familiar names, right? So let's see who is here. I see Kinja is here. Emmanuel, Tom. Got a notification too. All right, thank you guys. So you guys are able to have set up notifications, and I guess when streaming starts, then you guys say, "Hey, it's going on." All right, I see Anna is here. I see Etorna, Emordata. Hello guys, Lyndon. All right, thank you guys for joining for office hours. I had technical difficulties yesterday, so I had to cancel them, unfortunately. So I would have to figure out how to reschedule that. Hopefully we can have less technical difficulties going forward. And all right, and someone said just open up the playlist or the YouTube link. All right, so you guys are able to get this link. That's good to know. I want to make sure people are able to access the office hours. So thank you for that. All right, so with that said, hopefully everyone is doing fine today. I see the familiar names. Welcome to Unit 1 office hours. Today is, at least where I'm at, is October 7th on a Wednesday. So let's go ahead and wrap up our discussion about decorators and closures. We'll see another example that will kind of probe our understanding about functions, understand where it's a good place, where those fit using decorators. We will make our progress with the IP mini project. So let's continue to march our progress on that mini project. All right. Hello guys. So let's see other agenda, other topics you want to throw on this agenda. Let me know. I'm going to get my water, so I'll get a stand up here. Let me know what additional topics you want me to discuss for today, so I can put on the agenda. But currently, this is a plan right now: decorators, enclosure, and the IP mini project. Okay, by the way, I'm drinking tea right here. That's what I'm drinking, but I also have water. All right, someone's saying they're having a lot of trouble with the server. I lost a connection all the time after around 10 minutes. Is anyone else having the same problem? Your connection should not be shutting down. However, let's see. Okay. All right, let's take a look at what you are saying. I'm having a lot of issues with the trouble. I lost a connection all the time after about 10 minutes. So sometimes it could be an issue on your end, not having a stable internet connection. Sometimes it could be an issue where it's at a capacity. The pods we've allocated are at capacity. Unfortunately, this is a large class. This is, I think, about 3,000 people in it. So sometimes demand exceeds capacity. I don't have a better answer behind that, but you should not, once you have a pod, it should not die at around 10 minutes. There is culling. In other words, if you are inactive on your account for about, I think it's about 60 minutes, it does shut down. However, that is not 10 minutes. So, yeah, Anna, when you say you lose connection, do you see an error message that pops up? That'd be interesting to see on my end. Something like the server doesn't respond. All right, so if that issue occurs again, go ahead and do an internet speed test. I just want to make sure if it's not on your end, because that might happen. If it's on your end, then it's on your end, unfortunately. But when that happens, check your internet connection, because if you don't have a stable connection, that might cause the issues. That might be the source of error there. And when you say the server doesn't respond, as in you're running cells and nothing is kind of hung up, right? Just nothing. You run a cell and nothing happens. Sometimes it's useful to reconnect. Sometimes this might happen. You can go, let's open up new, Python 3. Hello, guys. I see some more people have joined us for today. And for example, let's go open up a new notebook for today's office hours, October 7, 2020. And sometimes you might want to do kernel reconnect. You might lose that connection to the kernel. Your pod is still active. So you might want to go into kernel reconnect. All right. All right, so I see someone posting about a mail about a week's office hours at 10 p.m. in India, but it happened at 6 p.m. So we alternate the times of office hours. So for today, for the Monday, Wednesday slot, it occurs at 12:30 UTC. That's the Monday, Wednesday slot. Tuesday, Thursday, they occur at 20:30 UTC. So they are at different times, but all the time zones are based on UTC. So maybe you thought of it's the same time every day, because that is not the case. And yesterday, unfortunately, I had to cancel office hours. So if you did show up and there was nothing there, it's because I had some technical difficulties and I had to cancel them. All right, so I'll go ahead and keep an eye on the chat, what people are saying, but let's take a look back on Clojure and this decorator concept. Let's go and revisit what we did. I'm going to go ahead and open up the old notebook, and by the way, I post these notebooks on the shared drive, so you guys have access to that. Wrong notebook. Is it this one? All right, I believe it's this one. And here we had this convert to function decorator. Right, the convert to Fahrenheit. Now let's go ahead and take whatever was that, calculate the temperature function. So I'm going to run that. Oops, wrong thing I want to copy. And where is calculate temperature? So I had this function called calculate temperature. And this returns temperature in degrees Celsius, but I had this decorator that's going to modify the behavior of this function, modify the output of this function to convert it into Fahrenheit. And then we saw the syntax here. I said calc temp modify. And you can think of this decorator as a kind of a factory. It takes in a function, and what it returns is a new function. And you got that new function, and you can proceed to call that function. So calc temp mod for modified convert to Fahrenheit, calc temp. We run that, and we run the calc modified version, calc temp modified. And accepts 2 arguments, sorry about that, accepts 2 arguments, and I get my answer. Now this is, you might say, okay, well, it just really cut down on 1 line of code, but maybe we'll see another example where we cut down multiple lines of code, and we see more beneficial behind these decorators. Now, my question to you is, what is the current problem with this decorator? Any problems with this decorator? Perhaps it's limited in what it can work on. What are your suggestions? All right, number of arguments, exactly. As Dedenola brings up, the number of arguments is we're limited to this decorator by the number of arguments. So does that really mean that if I have another function, let's say calculate temperature process process A, and accepts 3 arguments, and this might model some sort of, I don't know, geologic process, right, that accepts 3 parameters and returns a temperature. And then I want to modify this, calculate temperature mod, and I say convert to Fahrenheit, and I pass calc temp process A, and then I call that, and then I say 1, 2, and 3. Well, wrapper takes 2 position arguments, 3 were given. Does that really mean I need to create a new decorator when it has 3 arguments, and then another decorator when it has 4 arguments? That's not so great, right? This is not really so useful. However, as you can tell from my tone of voice, there is a solution to this problem. I want my decorator to be general purpose. In order for me to do this, I need to be able to write out functions that accept an arbitrary number of arguments. Exactly. As Kin just showed, we're going to use star args. So in Python, there is a way we can define a function to accept an arbitrary number of arguments. And that is through the star args. So let's do that. Let's go back here and say that this wrapper function is going to accept an arbitrary number of arguments. That's what star arg means. Here is that when someone calls this function, they can pass an arbitrary number of arguments, 0 all the way to infinity. Someone is asking what is the difference between star args and star kw args, and we will examine that just right now. But let's take a little, we'll examine that in a couple minutes. So I'm going to define a function, my function, and I want this function to accept an arbitrary number of arguments. So I say star args. And let's go ahead and print the type of star args. Let's just see what happens of args. Define my function. And we'll also print out args. So let's try it out. My function 1 and 2. And notice the type of args is a tuple. And I print it out, and sure enough, I see a tuple. So what Python is doing is when you call this function with an arbitrary number of arguments, what it does, it takes all those arguments and it puts them together in a single object. And it uses a tuple. So here Python takes all those arguments and combines them into a single object that is a tuple. Let's go ahead and try that out. Let's go in my function, and let's say 1, 2, and 3. 1, 2, and 3. We can also have said 0. It's an empty tuple. Questions about star args before we talk about kw args? All right, someone says heap priority list. All right, we can put that throw on the agenda. Heap queue and priority list. I'll throw that on the agenda. May not get to it today, but a good topic for perhaps tomorrow's office hours or Monday. All right, so think about algorithms. Think about algorithms. All right, thank you. I'll throw that on the agenda. I can wrap someone's mind around them. Thank you. All right, any questions about this arbitrary number of arguments? Okay, let's talk about kwargs. So a function, my function, can accept positional arguments, but can also accept keyword arguments. So for example, I can define a function accepts 2 positional arguments and a keyword argument. And let's say if verbose, then it will print a and b, and maybe it just returns a plus b. Very simple function. Accepts 2 positional arguments and 1 keyword argument. Now, we know how to write an arbitrary number of positional arguments, star args. How do we go about writing a function that accepts an arbitrary number of keyword arguments? Well, what we do is we define my function. I can say star args, and I say, star args, and I say star kw args. So now what this means is the function accepts an arbitrary number of arguments and an arbitrary number of keyword arguments. And we understand that the type of args is a tuple. But let's see what the type of kw args is. And by the way, the name of this here, args and kw args, is arbitrary. It can be whatever you want it to be. However, there's a strong convention in Python that we use args and kw args. So let's try that out. Let's pass 1 and 2. And let's pass a couple of keyword arguments, b, and a and b, and maybe help, true. And notice what happened. So Python takes those position arguments, puts them together as a tuple, but then what it does for the keyword arguments, since keyword arguments are basically a variable tied to a value, a key tied to a value, the natural data structure to use is to combine all those keyword arguments as a dictionary. Positional arguments, we place them by its position, so we use a data structure that's all about position. So we use a tuple. Keyword arguments is all about specifying this key has this value. This variable has this value. So it makes sense for Python to put all that together, all those keyword arguments, as a dictionary. In fact, let's print out kwargs so we can see how it looks like. And there it is. We see a dictionary that takes the keyword and the value passed. All right, someone's saying, can you please go over how to call the decorated function? We'll go ahead and see that a little bit. Okay, so now we know how to write functions to accept an arbitrary number of arguments and an arbitrary number of keyword arguments. So that means we can go back here and say, okay, our wrapper is going to accept star args, an arbitrary number of keyword arguments. And now I've modified my function. So then I can go here. Let's examine how we can use this decorated function. This function accepts another function that's going to modify. So it's going to return a modified version of this function here. And now let's try it out. I get a name error. So let's examine what that went there. It's because I'm still using A and B. So what I really need to do is I need to pass args and star KW args. I forgot about that. I modified the signature of the function, but I forgot to modify this part here. So what this is saying here is, let's take all those keyword arguments, all those positional arguments, and all those keyword arguments that were passed, and let's pass them into the function. And by the way, this is called closure. What we're doing here is a closure. We're making use of this function here. This is called a closure. Let's modify that there. And let's try that out. And now I get my answer. Questions so far? We'll see the at syntax just in a bit, but questions about the keyword arguments and modifying our decorator to accept a function that can accept an arbitrary number of arguments. Right, so it's now very general purpose. All right, let's go ahead and practice on another decorator. Let's create another decorator. Other questions can come up, but let's go ahead and talk about another decorator. What if I want to be able to time how long a function takes? And by the way, Jupyter Notebook, there's a time it functionality already included. So we are going to replicate something that already exists, but let's go ahead and do this for using decorators. So they do provide a time it functionality. This is taking a while. Looks like it's kind of hung up there. Let's see what happens if I do kernel reconnect. Yep, there we go. That seemed to have fixed it there. So let's define a way we can time how long a function takes. So what I could do is I'm going to import time. Time here is from the Python Central library. It allows me to do a lot of time functionality like sleep and check what the current time is. So what I'll do is I will say t0 equals time dot time. So this here is going to start the stopwatch. So it's going to find the current time basically. And then maybe we can go ahead and use one of these functions. Maybe this calc temperature process A. We'll call that function. 1, 2, and 3. And we want to see how long it takes. So then what we do is we figure out, we say time dot time minus t0. And this here is equal to the elapsed time. And we'll print out a message that says the elapsed time is t elapsed seconds. All right, let's do this process here. Let me go and recap what we did here. When we call this time function, what it does, it gives us how many seconds have elapsed from right now since January 1st, 1970. It's a starting off point. And then we call it again. It says, okay, tell us the number of seconds that have elapsed since January 1st, 1970. So we can figure out the difference, how much seconds have elapsed in between. And then once we figure out that elapsed time, we'll print out a message saying this is how long it took. I'll run this cell here, and yeah, it's a pretty simple process, a pretty simple function. So it is done in 1 times 10 to the negative 5 seconds. So rather quickly, it executes. Now, what if I want to do this for various functions? I want to time all the functions that I have, or various functions that I have. Well, I can do it again. I can go ahead and copy and paste this, and then just change the function I'm using. I get a name error because I think it's just called calctemp. I'm not sure about you guys, but every time you find yourselves copy and pasting, you might be doing things inefficiently, because what you want to do is you want to adhere to this principle called DRY. And DRY stands for do not repeat yourself. So in your coding, if you find yourself duplicating a functionality, then you are repeating yourself. And the problem here is you're going to have longer code, and longer code is harder to maintain. And the other thing is, well, if there's a problem with one part of the code, so maybe this functionality is duplicated in 2 parts, here it is and here it is, and there's a problem here and you fix it there, you might forget that it's duplicated here and forget to fix it here. So you find yourself doing things repeatedly, you should stop and say, hey, maybe there's a better way to go about it. Maybe I should encapsulate this as a function and just call that function when I need that functionality, when I need that behavior. Or maybe I would use a for loop. And in here, what I'm finding myself is I want to time the execution of a function. And I want to do this for the functions that I have. So maybe what I should do is define a decorator that I can use to decorate my functions. So now let's take this logic here and create our timeIt decorator. So we'll define my function, we'll say timeIt, and what it accepts is another function. That's the core thing about decorators. What they do is they accept another function. And then what we're going to do is restart off defining the inner function. And this inner function here is going to encapsulate the modified behavior. We tend to call it wrapper because it's sort of something that wraps around the original function, so call it wrapper. And it should accept an arbitrary number of arguments, position arguments, and an arbitrary number of keyword arguments. We want this wrapper, we want this function to be all-purpose. And the steps we've outlined is find the current time, run the function, and then find the elapsed time, and then we will print message and finally return the result of calling our function. Those are the steps I've outlined of what this decorator should do. Any questions at the moment? I'm going to show you some examples where decorators are used in real life. So I will get to that. But any questions at the moment? All right. If not, let's go ahead and start fleshing this out here. All right. So the first thing we do is find the current time. So we can say t0 equals time.time. Find the current time. And then what we do next is we say, okay, well, let's go ahead and call the function, which is called func, pass the all those positional arguments, all the keyword arguments, and assign this to a variable called result. And then once we've run that, well, let's figure out how much time has elapsed. So we say t elapsed is equal to time.time minus t naught. We can print out our message here. The elapsed time is t elapsed seconds. And then finally, what we should do is let's return this result. We can't forget about that because we want to modify the function, but we also want to get back the result, right? So let's not forget return the result. And finally, the outer function is going to return our wrapper. Remember, this entire function, what it does, it accepts another function and it returns a new function. And that new function encapsulates the modified behavior. Let's run this cell here and let's try it out. All right, calculate process B, and I call this calc temp equals time it. And I will call this calc process A timed. And I should have called it calc, not cal. And calc temp process timed, and let's accept 1, 2, and 3. And there we go. The elapsed time is so many seconds. Questions about this time it right here, this time it decorator. We'll see a better way to use decorators. Someone is asking, what is the use of decorated functions? And the use of decorated functions is that oftentimes a Python package will provide you a function that will allow you to modify your functions. And this is great because if you have a lot of functions and you want to modify their behavior, you don't want to go into the code and change it. Because if you change it, then maybe someone else wants the original functionality. Maybe you can program the dual functionality, but that gets a little more complicated. It might complicate your function. So decorators are a nice way where you can easily modify behaviors of functions, and it scales nicely because you can define your decorator and then use the decorator when it's needed. Now the problem with this approach here, we're using decorators, it's sort of an annoying process. We take our we take our function, we pass it through the decorator, we get a new function, and we call the new function. What if instead I always want to modify that function behavior? I want to avoid this two-step process here. So someone is, what part of the function are we modifying this example here? So let me clarify, is we're not modifying the original function. Instead, this wrapper here is going to basically modify not necessarily the behavior of the function itself, because we're not modifying the code of the original function. We are returning a new function that behaves a lot like the original function, but a modified version of it. So that is why we're not modifying the original function. This is the original function here. We're still using it, but what we get out here is a new function that's a lot like the original one, but with the modified behavior. And the modified behavior is, well, we check the time, we run the function, we see how much time has elapsed, we print it out, and we return the result. So let me clarify that, because I think my language is a little sloppy, but we don't modify directly the original function. What instead we do is we get a new function that behaves like a modified version of the original function. In fact, it uses the original function, but there's some modifications about the behavior. I don't like this two-step process here. I don't like this here. So there's a better way to do this in Python, and that is through the @ symbol. So let's say calc temp process steps A and B and C, and it returns 1 plus A plus B plus C. And if I always want this function to have the modification, what I do is I use this @ symbol and the name of the decorator. And you can think of this as a hat, right? We can think of decorators as modifying, right? You put a little party hat on this function, and that's what we do here. This here is called syntactic sugar. Every time you encounter the word in programming syntactic sugar, what that means is some sort of functionality that's not really needed, but it's sweet and nice to have. Just like sugar is sweet and nice to have, this here is called syntactic sugar. We don't need it. We can go about without using it, but it's a nice little feature. It's a little treat for us. So now when we use this @timeit functionality on top of our function, then it will automatically modify. It will automatically use the modified function. In other words, calc temp process A, 1, 2, and 3, and I got my modified behavior. Notice this cut down this two-step process where we create a new variable, that's the new function, and then call the new function. So nice little syntactic sugar. I know someone brought that up last time. What's about that @ symbol? That's what this does here. Show you something. This here is a code on deploying a web application in Python. In fact, we can see this towards the end of our time. Once we've built up our core strengths of Python and data analysis, we can work on a project together. And this is what we did last time for the last cohort, and we created a web application. In order to create this web application, we used a Python package called Flask. Yeah, and I will share those notebooks, by the way. Keep in mind that they are shared. If you go into your into the account, video downloads, office hours notebooks, I put them there. So here we create a web application using a Python package called Flask. And what Flask does, it provides these routes, it creates these routes, and the way you do it is using a decorator. So while you may not have to write your own decorators, that's probably not going to be necessarily the case, you might have to rely on a Python package that says, hey, here's a decorator. Go ahead and use it for your functionality. And this is an example here where we're doing it in Flask. When we see Flask later in the course, we're using these decorators. So you can think of it as, hey, this here, while we may not understand what Flask is doing, every time we see this now, it says, we define this function called main, and we're using this decorator. So we're probably modifying how this function works, the behavior of this function. I can show you other examples of decorators that might come up. We can even stack decorators together. So if I go back here, I can say, what do I call it? Convert to Fahrenheit. So now I'm going to modify the behavior function to convert the temperature to Fahrenheit and also to time the process. And there we go. I stacked two decorators. And the order of operations when we stack multiple decorators is we call the first one that is used is the one closest to the definition. So this one first convert to temperature, and then we do the time it. Questions about decorators? Okay. All right, so why would you add the dunder names to functions? Okay, so yeah, so you might have seen things in, for example, this dunder. What Python does is there are special variables and special names in Python, and in order to avoid a situation where I call something main that might clash with that, what Python does is I'm going to call that dunder something dunder. And dunder is just short for double underscore. And the whole thing is hoping the fact that you probably won't call something naturally double underscore something double underscore. It's a little awkward. So Python says, I'm going to go ahead and use those awkward names for special things. So they refer to special things in Python, special functions, special variables that hopefully you don't going to use yourself because they're a little bit awkward to write. So someone is saying, so decorators are functions itself. Yes, decorators are functions that accepts another function, and what it returns is a new function with a behavior that is a modified version of the past function. So if I were to sketch that out, all right, we can take our decorator. So this is our function, our original function. Spits out some values, here it is. And we add a decorator over it. All right, a little decorator. I don't know why I draw a little house. And then what it returns is a new function. And then we can use that new function. All right. I see someone saying, just to clarify again. Let me know if there's a further thought to that or if you want me to clarify something. But hopefully you see the usefulness of decorators. Like I said, you probably won't be writing your own, but you're probably using other Python packages that provide decorators. Okay, let me know if there's any follow-ups here. I'm going to go in, let's switch our gears and go into the IP mini project. Let's explore that. I'll take a look at the chat for additional questions about decorators. Let's go back to Q3. So what we want to do here is for a given Mercy number with exponent p, the number is going to be prime if we take the Lucas-Lermer series and we notice it has a value of 0 at position p minus 2. So in other words, we take a p-value, let's say 5. We can take that we use that exponent to calculate the Mercy number, and we know it's going to be prime if its Lucas-Lermer series is 0 at position p minus 2, in this case 3. So this is a good test for prime. We're going to use this Lucas-Lermer series to test whether it is prime. So what we want to do for this question is we want to go ahead and look at all the exponents. We're going to sketch out our strategy here. So for our strategy for Q3, the first step, let's go ahead and find all p-values that are prime from 3 to 65. And then what we'll do is for each p, we will get its Lucas-Lermer series. And now that we have the Lucas-Lermer series, we can check if it's prime. Check for prime using the Lucas-Lermer series. And then what we want to do is return the results as P and 0 or 1. Return a list of the results of P and 0, 1, 0 for it not being prime and 1 for it being prime. That's the strategy here. Let me know if there's any questions of what we want to do for Q3, but this is our overall strategy. We're going to find all the p-values that are prime from 3 to 65, those exponents, and then from there, generate the Lucas-Lermer series and do that test. Let's see it has a value of 0 at position p minus 2, because if it is, then it's a prime. That's our overall strategy. Let me know if you have any questions. Let me take a look at the chat right now. All right, so I see a question about the function argument is given arguments because the original function is going to require the arguments. That is correct. If we go here in our decorator, this here is the modified function. And the modified function is going to accept an arbitrary number of arguments and an arbitrary number of keyword arguments that it proceeds to pass them to the original function. And the main function right here, all it cares about is give me the function that you want to have the modified behavior for. I like to think about this as the factory. This is the factory, so it says give me the function you want modified, or give me the function you want to get a new function with a modified behavior of it. This here is the actual modified function. All right. Let me know if there are any questions about the strategy we're going to take for this question here, or if there's any follow-ups to decorators. Someone is saying, is the modified function always called wrapper? And the answer is no, it's arbitrary. The name of this function is arbitrary. Python says, hey, do whatever you want. Python's very flexible for that regard, for better, for worse. However, this is one of those strong conventions that we often call this wrapper. Yeah. And make sure you return its corresponding name right there. Okay, so let's go ahead and look at Q3, but let me know if there's additional follow-ups. So we look at our strategy. The first thing we do is we're going to get all the primes from 3 to 65, and then get its Lucas-Lermer series and check for prime using the Lucas-Lermer series. So let's go ahead and focus on this functionality right here. This functionality right there. So we have a function that gives us the Lucas-Lermer series. So functions can call other functions. That's the beauty of these things. You can think of functions as sort of a tool, and we can start configuring these tools to work together. They're very key building blocks of our code. So we can call this Lucas-Lermer sequence, and that is Lucas, called a Lucas-Lermer function for a value of p. And now we have the sequence. And what we need to do now is let's use a check. So we know that if the value of the series is 0 at position p minus 2, then it's prime. So let's check it out. Right? If Lucas-Lermer sequence at position p minus 2 is equals 0, then we're going to return 1. Else, we'll return 0. Someone is asking about Flask, and we will talk about Flask in office hours towards the end of the course. I think it's a good thing people to know and a cool thing people like. So it's not part of the core curriculum, but it's something I very much want to lecture on during office hours. And Flask enables us to create web applications in Python. So we can take all the stuff we've learned throughout the curriculum and combine it and create something using Flask. Okay. So now we run this function here. Let's try it out. Let's go ahead and say Lucas Lemmer prime for a value of 5. And we get 1. So this is telling us here that it's prime. All right. Any questions, any follow-ups behind this Lucas Lemmer prime function? Accepts an exponent p. I think I messed up. Because, no, I think I'm fine. Because when we give it a Lucas Lemmer function, it creates the series, right? Let's say, let's see, Lucas Lemmer. Yeah, it's fine. Accepts p. Sorry about that. I think it's fine. I think it's working out. All right. So now we can go ahead and do our answer. So let's use list comprehensions. And comprehensions, as you've seen, is a compact way you can create a new data structure by iterating through an old data structure. And the recipe of comprehensions, the way I think about the recipe of comprehensions, is there are 3 pieces to comprehensions. There is the recipe. In other words, how to create a new member of the data structure using an old member. So the first part is the recipe. What follows is the for loop. The for loop right here. And what comes at the end is optional, and it's a filtering condition, some sort of filtering. So comprehensions take 2 things, an optional third. And comprehensions are a way to create new data structures through iterating through old data structures. And when I write comprehensions, I always start with the for loop. Because when logically that's the first thing you do. You iterate, you do your for loop first. So I like to write the for loop portion first. Then I ask myself, is there any filtering we need to do? Maybe we only do this for even numbers, odd numbers, or we only do it for things that are prime. So the filtering condition, which is optional. And then finally what I put up in front is the recipe. How do I go about creating a new member of the data structure through the old values? And since we're going to do list comprehensions in this example, we use square brackets. So we can do this without comprehensions, but let's focus on comprehensions. It's sort of Python's way to go about creating new data structures through iterating through old ones. It's a very common style in Python, so we got to get comfortable through comprehensions. I know when I was learning Python, comprehensions were a little bit weird. I was like, what's going on here? But after a while, it kind of clicked to me. So let's practice with that. Let's go to the IP mini project. And what we want to do is we want to go through the p-values that are prime. So let's do the for loop first. So for p in range, and I want to go through, I believe, 3 to 65. So 3 to 65. And let's check if it's prime. And we have that function to check whether p is prime. Now we have the, I think it's called isPrime function. So let's use it. So I go here and say if is prime, value of p, and what we want to create is a set of tuples with the Mersenne exponent and whether it was prime or not. So we create a list of tuples. So what goes right here in front of the for loop is the recipe. What are the members of that data structure? What are the members of this list? And that's p, and whether it is prime, which we can check by calling this function here. So notice we can construct the new members of the data structure by calling this previous function, this function we defined. Lucas Lemmer prime, put a value of p there. So let's go ahead and examine what we're doing here. We're iterating through 3 to 65, We're going to check if it's prime, if P is prime. If it is, we construct a new member of this ever-growing data structure that's a tuple of the exponent and the output of calling this function for that value of P. And we'll call this Mersenne primes. I think that works out. There should be 17 members. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I think this should work out. Questions about our approach for Q3? If I look at the agenda, I do want to talk about heaps and priority queues soon. I do want to talk about that, so thank you for bringing it up. And once again, what I say is that sometimes the topics you bring up, I may not talk about today, but I do put it on the agenda. I do say that agenda for future office hours. So I do appreciate your patience while we go through these topics. All right, so if there are no questions for this Q3, there might be, feel free to put those. Let's revisit this function here. We talked about how it's cool to use comprehensions, but we didn't do comprehensions here. So you might be wondering, is there a way I can use comprehensions in this case? So let's see if we can rewrite this function to make use of comprehensions. Let's try that out. When I take a function and I fix it up, perhaps to make it more efficient or make it more readable, that's called refactoring. Remember, one of the goals we want to do is we want to write code that is readable, that is understandable, because that leads to code that is easier to maintain. So let's see if we can modify this function so that we use comprehensions. And it's a little tricky because what is happening here is that all the members of the sequence start off with 4. So my strategy here is, okay, if all the members of this series always start with 4, maybe what I can do is I can do comprehension for everything but the first sequence, position 0. Do comprehension there, and then combine and insert 4 as a first position, as 0 position. So in other words, what I can do is say for I in range of 1 to p minus 2 plus 1, and I'm going to create my sequence here. But this is tricky because it makes use of the previous value. So what I could do is I'm going to have, let's create a new function. Generate sequence. Generate member. How about that? Accepts a value of I. And what I'll do is if I is 0, return 4, else return. Okay, it's going to be a little complicated. We can rationalize this. And then I'm going to make use of the previous sequence. This might be a little tricky to do with comprehensions. I think there is a way. I have to call upon the previous value of my sequence. Maybe this one's a little tricky. Maybe this one's not so clear how you do a comprehension. I have to think about this. Thought I'd be able to do it right now in office hours. All right, anything people want to bring up for office hours? If I'm take a look at this agenda here, I do want to talk about this, so maybe I can talk about this tomorrow. And then this might link up together by thinking about algorithms. This one here is one of those things where we'll kind of keep on having our thoughts in our minds as we go through office hours. Okay. Office hours tomorrow will be at 2030 UTC. So if you go onto the pod and you go into video links, it should automatically convert the times to where you are located based upon your IP address, I believe. However, keep in mind that the office hours are on Monday, Wednesday occur at 12:30 UTC. Put this in the chat. So Monday, Wednesday, 12:30 UTC, and then Tuesday, Thursday, the office hours are 20:30 UTC. All right. Anything people want to bring up right now? We're at the end of office hours. All right. Someone is asking for the WhatsApp group, so feel free to post that for Joseph. He's looking for the WhatsApp group. Someone's saying, can you see the missed office hours? And yes, that is put on this playlist. So we have this playlist right here where we put the past office hours videos. However, there was no office hours yesterday because I had technical issues, so I was able to stream office hours. And Joseph, if you go onto the forum, if you go into our Ask forum, I know people have posted about, you go to QU Ask, DS Train, people have posted the WhatsApp link. It's unofficial, it's not maintained by WorldQuant, but people have created WhatsApp links, so take a look at the forum. With that said, guys, take care, have a good day, and see you tomorrow.